How to handle non-perfect squares in GED Pythagorean Theorem. Have you ever found yourself puzzled by non-perfect squares while working with the Pythagorean theorem on the General Educational Development Test? You are not alone. This is a common challenge, but with the right approach, you can tackle it confidently. The Pythagorean theorem is a fundamental concept in geometry. It tells us that in a right triangle, the sum of the squares of the two legs equals the square of the hypotenuse. In mathematical terms, this is expressed as a squared plus b squared equals c squared. When you encounter a situation where the squares of the side lengths are not perfect squares, it can feel tricky. But don't worry, you can handle this step by step. First, calculate the sum or difference of the squares as you normally would. For example, if you have one leg measuring 3 and the other leg measuring 4, you would calculate 3 squared plus 4 squared. This equals 9 plus 16, which gives you 25. However, if you find that the result is not a perfect square, you will leave it as a square root expression. For instance, if you calculate a squared plus b squared and get 50, then the missing side length is the square root of 50. Next, you can simplify the square root if possible. For example, the square root of 50 can be factored into the square root of 25 times the square root of 2. This simplifies to 5 times the square root of 2. If the problem requires a decimal answer, grab a calculator to approximate the square root. You might round it to the nearest tenth or hundredth, depending on what the question asks. Always check if the problem specifies whether you should provide an exact answer in simplest radical form or an approximate decimal. This can make a big difference in how you present your final answer. Let's look at a practical example. Suppose one leg of a right triangle is 20 and the hypotenuse is 24. To find the other leg, you would use the formula c squared minus a squared equals b squared. You would calculate 24 squared minus 20 squared. This gives you 576 minus 400, which equals 176. Since 176 is not a perfect square, you will express the length of the leg as the square root of 176. Simplifying this, you find that 176 can be factored into 16 times 11, which simplifies to 4 times the square root of 11. If you need a decimal approximation, you can calculate the square root of 11, which is roughly 3.316. Multiply that by 4, and you get approximately 13.3. By following these steps, you can confidently handle non-perfect squares in the Pythagorean theorem on the General Educational Development Test. Understanding how to work with square roots and simplify radicals is essential for success in the mathematics section. So, keep practicing, and you will be well prepared for any question that comes your way.